Okay, so now we're going to look at three-dimensional shape. This one's a pyramid, and count how many faces, edges, and vertices are on that 3D shape. The point of this is just to get you more and more comfortable with looking at and thinking about 3D shapes, so that later in the course we're gonna do more complex stuff with 3D shapes. We're gonna in about a month or month and a half, probably month and a half, maybe 6-7 weeks, we're going to start looking at volume and surface area, like filling up a 3D shape or finding all the surface area if you had to paint it or something. So we'll do some more complex calculations at that point. So right now it'll help just to get more familiar with thinking about 3D shapes and kind of analyzing them. So let's count how many faces first off. Faces are like sides. How many sides are there to this shape? Total sides, including the bottom.
6.
Right. Did everybody see there's got to be 6 there? Let me help. Let me try to count them with you. So I'll try to shade them in. So like right here. Wait, I didn't do that too well. Okay. So there's one. There's that side, right? And then I could say, okay, here's another side. So that's 2. And then there's the back side. Over here, there's this little backside back here. Well, it's the same. It just looks little from our perspective. There's 3. And then we could go back here. That's 4. Excuse me. And then over here, that's 5. So there's the 5 sides. And you can tell that just by counting these edges. 1, 2, 3, 4. There's 5 on the ground. So that has to mean 5 sides going up. And then the very middle is number 6, because that's the ground floor, which I'm kind of running out of colors here. The ground floor, which is number 6. Yeah, so there's 6 total faces or sides, 5 sides around the side, and then the bottom. So 6 total faces. Now let's count edges. How many edges on this one? Try to erase all that. Edges might be a little easier. Let's just try filling those in as we go. So I'll just go, okay. 1, 2, 3, 4, 5 edges on the ground, and then 5 edges coming up. 1, 2, 3, 4, 5, total of 10. Does that make sense? 5 on the ground, 5 coming up to the top. 5 on the ground, 5 go up to the top.
Can you explain that one a little more?
So yeah, so just fill them in. I think the best way is just to fill them in as you go, on your own diagram. I think that's the best way to see it. So just every edge, just go ahead and fill it in. So I'll just go 1, 2, 3, 4, 5. So I filled in the 5 edges on the ground, and then the 5 going up. 1, 2, 3, 4, 5 going up. So 5 on the ground, 5 going up, 10 edges total. And now finally, let's do vertices. How many vertices are there? Vertices are just points. So how many total points? Go back to this color.
6.
1, 2, yeah, 3, 4, 5, 6. Looks like 6 vertices. Yeah, 5 on the ground, 1 at the top. 5 on the ground, 1 at the top. 6 total vertices, just like that. We good there?
We can also use the thing that you gave us on the notes, right? The
Yes, yes. Good observation, Paulina. Yeah, let me go there. Where is it?
because
Yes. Good.
that's what I was doing, and I just found the vertices and the faces, and then like I just found the edges like that.
Yeah, nice. Exactly. Yeah, does everybody see what Paulina's pointing out? So from the notes, I just added last time, this guy, his name is Euler. I know it looks like Euler. He's one of the most famous mathematicians in history. He's actually the one that discovered how airplanes fly, about air pressure going under the wing. And anyway, I won't get into the details. He's super famous math science guy from the past. It's kind of good to be able to pronounce his name, just because you're getting a college education. He's kind of a famous guy. Euler. So Euler's theorem, he had many things he discovered, like I said, airplanes and all kinds of things. Anyway, for three-dimensional shapes, he noticed that vertices plus faces minus edges is always equal to 2. Vertices plus faces minus edges is always equal to 2. Yeah. So in other words, getting back to this 3D shape, that means that vertices and faces, these two added together, vertices plus faces, that'd be 12, right? Notice it's 2 higher than edges.
1, 2,
So if
3.
you just add that and subtract 2, you'll get the number of edges. That's what Paulina's pointing out. It's a good observation. We don't have to do all 3 of these. We can just do like faces and vertices, add them up and subtract 2, and we'll know edges, for example. Or you could do any 2. You could do the first 2, and you get the third. Just however you want. You can save time, and you can also double check your answer with Euler's theorem. Vertices plus faces minus edges is 2.